We did it, right? Fantastic. Fantastic. I'm proud of you, Rob.
Oh, thank you. I didn't know I could even do it. I'm so in coma right now.
You are true grunge. You are true grunge. Here's the thing, you never have to worry about doing a little bit of bad karaoke for less than a minute.
Yeah, that's true. That's true.
Bad karaoke is incredibly entertaining.
Bad karaoke.
For less than 1 minute. After that, get off the stage.
At least we didn't do the over. When you think of karaoke, there's like particular songs that you always see people do. Like you always see them do Love Shack all the time.
Oh, that's just terrible. Yeah, Let It Be. Lots of Beatle tunes. And then occasionally, somebody will try a Journey song.
Yes.
And you can only do that for 15 seconds before people want you to... Yeah. What do you think, Mark?
Yeah, I don't know any of these songs, but it's great.
Really?
Awesome.
Oh, jeez. Well, you know what? We have to figure out what Spanish folks listen to.
Exactly.
Is it that you guys only listen to flamenco? I mean, I don't want to be stereotypical or anything like that, but
not at all.
Okay, I know that you like Queen, right?
Exactly.
Anything else?
Pink Floyd.
Huh?
This is crazy with Clubhouse here in Portland.
The hundreds of people in our room are laughing.
Oh, I no kidding. It's just ridiculous. It's out of control.
I'm just here just to learn about digital twins today.
Yeah. So
what are those things?
What is this? This is episode almost like 44. Wow. We're closing in on 50.
And we're making so much money off of this thing, which is like the awesome part. It's like all the checks that show up in the mail every week from this Coffee Talk deal. Ooh.
Keeps us sharp, man.
It does. It does. I know there's a payoff somewhere.
Yeah.
No, you're right. It keeps us sharp. We're talking about...
No, it really does. Stuff. I mean, so I think what inspired this particular topic and what we're going to be talking about today is digital twins applications, not necessarily digital twins themselves, but applications. Rob, you hosted a outhouse topic on digital twins, right? And
it definitely felt like an outhouse.
Yeah, we were all over the map with digital twins.
We were.
And so I thought it would be kind of fun to address some of these, I don't know what you want to call them, prototypical confusions about digital twins, and see if we can do some level say.
Prototypical confusion. Wow.
Yeah, absolutely. I have it.
Oh my God. Okay, we're starting. That's what we're going to call our band. Prototypical confusions.
And
Yeah.
there, are you there? Are you rehearsing live right there? Like, are you in La Jolla right now, right on the
Yeah,
beach? It
yeah.
looks like
Home
it.
home of surf grunge.
Surf
Yes,
grunge. I like that.
yes, yes.
Well, a lot of the grunge artists really looked up to a lot of the surf punk music that,
Yeah.
from the
Well, Eddie
80s.
Vedder. Eddie Vedder was a surfer, right? Think
Yeah,
about it. Those guys
absolutely.
wanted to somehow beachify the heavy metal, like the thrash metal stuff they were listening to, punk thrash metal. Yeah,
Da-
punk music was
Da-
huge with the surfers back in the day.
Dave Grohl was in punk bands before he
Yeah,
did Nirvana.
yeah. So yeah, we're gonna talk about digital twins and
Digital twins. What do we
applications,
do with them?
though. Yeah,
Applications for
yeah.
digital
And
twins. So
are
we're not
we?
going to sit there and pontificate about the twin itself, but what do we do with it?
Yeah. What the hell do you do with it?
Once you have a twin or a bunch of twins for friends, what do you do with them?
Yeah, yeah. Exactly.
Well, I think
Yes. Tell us what you think.
I think
Exactly. Tell us more.
friends, and I apologize. You can tell I'm looking down like I'm not paying attention. I'm peeing on people to try to get them in. Now, what I've noticed, see, look, I'm peeing on pictures of people, which you should all be doing.
Oh yeah.
Here's the funny thing I noticed: when I ping too many people,
Uh
at
huh.
some point the app says, we notice that you're doing too much of the same action in a period of time. So they think I'm like a hacker or something. And
Uh
so
huh.
then they prevent me from like pinging on anybody else. And so there's that. So basically, you're getting green stuff at the top saying, oh, so and so listen because they really care. And then you get a red banner that says no bueno, dude.
Yeah.
um, so think about, go back to IoT and just the idea of we're remoting something. We're taking something that's far away or maybe not that far away and making it local, making it digital. There's the physical thing. I either have to walk to see it and find out about its state, or I get in a car to go find out, or I get on a plane or whatever. And then magic IoT and some kind of connectivity, maybe wireless, the data about its state comes back to some server, maybe in the cloud, maybe in
Right.
your closet, and you have that state of it locally. Now, in the olden days, kids, you might just have the state of that in just columns of a database, right?
Yeah.
Or it could be shooting JSON files flying at you like ah, and how do you organize those and make sense of those? A digital twin is just one way that you could organize those. Instead of looking at something that looks like a spreadsheet, you could just see it's a twin of a thing. So it's an electric motor, and its temperature right now is 500 degrees, and the RPM is 10,000 RPM. It's going really fast, and you're getting that telemetry about it. But you could model that thing. It's a twin, and you could see that it's a motor, and it looks like something. It has dimensions. It's how fast it's going. Its temperature, a bunch of properties about it. And so that's another way of looking. And so now you're kind of looking at the digital live, and the real things maybe across the factory that you can't see. Now, what do you do with that thing, right? It's if the twin made it more easy to organize the data about it so that it looks like the thing and acts like the thing,
Yeah.
then it makes it good for you, easier for you to make decisions about it, whether it's a person acting on that twin, observing it, showing it on a dashboard, or if it's analytics looking at that twin. The analytics say, oh, okay, I'm looking at the twin. Oh, yep, I just did a lookup. Device number 9 million is an electric motor. And I can see that right now it's 500 degrees, and maybe that's a little too hot. And I can see the RPMs are, running at 10,000. And so I may have KPIs assigned to my twin that say, dude, you're in that red zone of the KPIs. Like when you're driving your car and your RPMs went too high, you redlined it, right? So it's the same thing. And so your analytics, because ultimately our success in IoT, if we ever get there, folks, the three of us may not still be alive. We may not see the day, people. It'll be on the other side of the mountain when IoT actually succeeds. But let's assume we get there. But if it does, machines will be doing all this stuff automatically. There won't be people monitoring. There won't be people making decisions because it'll be too big, right? So your analytics are looking at the twin of the electric motor, and they say you're in the red zone, and then maybe associated with the twin, in addition to saying these are the KPIs, maybe a good temperature is 100 degrees, and not so good is 200, and really bad is 500. And so there may be baked into the twin. So this is kind of, again, I apologize to all you twin purists, whatever that means. I'm just making twin stuff up myself because I can. And it's kind of, we're still in that winner takes all phase of the market, right? And so there's the Rob Tiffany twin that I'm going to win, right? And so instead of having data and my analytics, I wrote some code, some JavaScript code or whatever, and all my logic is there, I'm going to have maybe less logic in my analytics. That my analytics instead are going to do the equivalent of a database lookup. They're going to do a lookup. They're going to find out who this twin is. They're going to find out those KPIs. They're going to see the actual value. They're going to compare it to what we say is a good value. They will see that it's in the red zone. And then they may find out that we may have instructions inside the twin that says, hey, when you're in the red zone, maybe you should take this action because we need machines to take the action automatically. And so maybe in this case, the action is, another thing that happens sometimes in IoT, especially in control systems, is the idea of sending a command back to the machine. And so the logic, you're a bot, your agent that's looking, yeah, it'll send a command to say, hey, let's go chill that motor out and set it down to 5,000 RPM. And then let's take another reading on the temperature. Oh, okay, it's chilled out, and now the temperature's down to 100. We're in the green zone. Everything's okay. It's just another way of organizing data is the way to think of digital twins. And it was interesting in that conversation we had earlier in the week on the digital twin talk, where people were admittedly, I don't want to say skeptical. I mean, we had great discussions, but they're like, are we just creating yet another way to, some people are like, listen, I already have the data. It's the same data we always had. The person who was doing things manually, who went out to look at that machine and touched it, and it was really hot, they may have had instructions on a piece of paper, or they may have had a spreadsheet they're looking on a tablet and they're entering data, and that's what all this is. And so, we certainly don't want to do, and I kind of talked about, let's not, how you, I was, let's I have a prop here. Luckily, we have our Yamaha amplifier. And you notice that the volume on one side is 0. What's the volume on the other side? Is it 10 or is it 11? Ooh.
Or 100.
Yes. There are digital twin companies out there that build extreme twins of things. And I'm not just talking about like Microsoft finally coming to the party with Azure Digital Twins. There's companies that are making giant 3D models of container ships and aircraft and engines and things like that. And they're super complicated and they're 3D and they're beautiful. Like if you're using CATIA from Dassault Systems or something like that. There's that side of the world that's that extreme twin. And there's a lot of people who believe if I'm not seeing that, then I'm not really doing a digital twin. And then there's turn the volume down. And so, be pragmatic. It's just a data schema, and you could have whatever is going to add value to your solution as a customer. If it's just a minimal amount of data and some commands that make it work, fine. If you need the 3D model, do it. My fear always in the past, especially like when we were doing Lumada, was I didn't want to force people to have to do a really complicated twin in order to start using the system, because I felt it could become a blocker to adoption. If you know how people are like, wow, this is too complicated. I'm not even, and I know Mark is all about a simple, easy to use system, because the things.io is arguably one of the easiest to use systems. And so he was doing a great job of making it very approachable to people. Oh, I understand this value really fast. And that's key. It's more important for people to be able to get to value quickly than to maybe have the best twin machine, if that makes sense, Yeah. What does everybody else think? I need a sip.
Yeah, you do. I noticed something. You cannot completely mute Clubhouse. It pisses me off.
Even though your volume is down to 0.
You cannot. Yeah, you can. Yeah, it's super annoying. Anyways.
I
Yes.
have a
On that
question.
note,
well, Leonard, sorry, go ahead.
No, no. Actually, you go first because you never talk.
So, um, I never got into like a very big volume of this digital twin concept, but but I really like the simulation concept on statistics. So how simulation applies into the digital twin concept?
Yes. So it's because you're right. A lot of times we've been talking about kind of the runtime twin or the in
Yeah,
production.
reactive, right?
Yeah,
Or even
exactly.
a kind of bit proactive.
That's exactly right. So when you talk about the simulation twin, it's where you have the software, like data's flying in and events are firing. All these IoT systems and stuff, they're all kind of event driven. An event happens and I do something, right? And so a lot of times data arrives that it's an event and maybe my analytics looks at it. So an event happens, and there's that comparison of all the things in the twin. So when you want to do a simulation of something, let's just stick with our little electric motor. Maybe we're designing the motor this time around, and it doesn't exist yet, but we want to create a digital version of the motor first. What you want to be able to do is the twin is alive, or the twin is still a definition and what to do when things happen, and the bot's still looking, but you could send fake data into the system pretending it's a motor that doesn't exist, and you're trying to exercise. We want to find out, how is this thing going to react? I think the best example in the real world where we test things like cars or aircraft to find out stuff about it before we let people have it is a wind tunnel. You know how you see TV commercials where they put a car in a wind tunnel and the air's going over it, or they do it and that's they're trying to simulate, aerodynamics and things like that, and drag coefficients. It's kind of like that. And so you're going to force fake data at your twin, and maybe your twin is expecting a whole bunch of different data, because that's what IoT is. It's a multivariate system, folks. And all those data points are coming in, and there's reactions to every one of those data points and actions that will happen, and how it reacts. So when you start slamming, I'm just now telling my twin that the RPM is running at 10,000 and the temperature is really high or something like that, we're going to see how does it behave. Now, there could also be, like I'll hear people talking about twins of simulations of like wind farms, like the big wind turbine windmills. And when the wind's really hard, and they're doing really complex simulations, like they can tell, is the thing starting to tilt, like the whole structure of the windmill, is it starting to bend? And so they've got telemetry on the things you care about, like how fast it's going and how much electricity is it making, but the structure of it itself, is it flexing? Is it bending in the wind? Is it going to break? Things like that. Those are all, I think it's the holy grail. I don't think everybody's gotten there yet. I think people talk a good game about simulation twins. I think some of them work fine, but others are probably hard to do. But I think that's where a lot of people want to be, is have this living thing, and you can simulate and find out exactly how it's going to behave as if it was in the real world. It's a journey. We're trying to get there, I think. So it just depends on what it is, I think, and how
depends on what you're going to do, right?
The quality of the inputs and outputs you're going to have, right?
And the economics of it. Is it even worth simulating off of a digital twin? Obviously, it reduces the cost for certain types of simulation activity that you're doing, like let's say for testing the aerodynamics of a car. But out in a vineyard, it's like, what do you want to simulate? Maybe you can simulate the weather and how microclimate shifts can impact the crops, but then that requires you to create digital twins of grapes and all the elements of a vine. And I think
could get crazy.
Yeah, and so going back to one of the comments that you made, and it was something that was brought up in the conversation that we had earlier in the week with that Clubhouse group that you started, or that room that you started, was this whole idea of attributing behaviors to a digital twin, right? And you kind of touched upon it in two ways. You could either have the digital twin have behaviors, and think of it out, if you're an object-oriented programmer, like methods for a particular class or object, behaviors for that particular object. So one of the things could be the stress tolerance of a material. If you're testing, if you're doing the whole modeling thing and you're trying to, let's say, test the stress tolerance of a part, having methods that basically represent the physical behavior and, let's say, the twins' reaction to certain physics, right?
Yeah.
And then there's the other thing that you mentioned, which was what you did with your stereo, right? If the volume is too high, then maybe the digital twin is unaware of certain type of logic that tells you, okay, look, it's too loud. Maybe you should turn it down, right? But I think that's where people might get a little bit confused, because I think the latter is more of the application, whereas behavior that is characteristic of the actual object that you're creating a digital twin for may be a logical extension of this idea of a digital twin, right? Because in previous discussions that we've had about digital twin, we've talked about behavior. I think it was one that we had with Rick, and you and Rick were like kind of going back and forth on the topic. Yeah. But I think where people get confused is when we just like IoT. If we start overloading things, then people get confused, and then they start saying that everything is a digital twin, and then the entire system is a digital twin, right? But I think as an architect, someone who's designing solutions, we need to be very clear about what a digital twin is. And so that's why I thought that conversation earlier this week was really kind of at least enlightening for me. And because I was just observing everyone talking and the questions that are being asked, I'm going, oh, wow, we're all over the map. You know what I'm saying? And then you look at the names and the titles of some of the folks that were in that meeting. It's like, okay, there's a huge diversity of thought, and some of the stuff, makes sense. Some of it doesn't quite make sense. Yeah. So I think that's why, we
had folks who worked on digital twins at GE when they were building the Predix thing, because digital twins was at the very heart of what GE was doing as well. Yeah. And it makes sense because, even though we normally attribute digital twins to NASA and Dr. Greaves talked about it a while back, but we think about it, it really mostly was used in manufacturing, right? Yeah. And so it makes sense that GE would be all in with digital twins. They used to have a really cool conference. I don't know, it was like Mind and Machines. When they were in their heyday of GE Digital doing their thing. I always thought what was good too is how we discussed about people as digital twins. Like we talked about, we're all wearing headphones right now and turning the volume up to 11. If part of the properties of you are your ears and your eardrums, and then you could talk about behaviors and reactions. If the volume's too high, you could say there's pain, and you could say at some point you'll rupture the eardrums. And so when you're trying to model out a human system, right, as a twin, that's kind of what you would do, among other things, right? Those are I think we're heading that way with people, actually. I love talking about people as twins.
Well, I mean, if you have an iPhone, just open up your health app. Well, yeah, that's the beginning, right?
It is.
So you're absolutely right.
The watch, your Apple Watch, your Fitbit, whatever. Those are the beginnings. Remember a long time ago, what did they talk about? Not the actuated self, the something self. What is it?
Whatever. You know what? That's a term I always forget. It's the instrumented self or something like that.
Yeah, I'm sure the hundreds of people that are listening are going, Rob, it's the blah 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 self. That's what it is. But quantitative self. Quantified self. Yes, that's what it is. It's the quantified self. And it started early days with I'm just tracking your steps. Now I'm tracking your heart rate. Now I'm doing blood glucose level. I'm tracking
where you are. I'm tracking.
I know these guys, Sensoria, that makes this. They make a lot of things, but they start off making socks, like IoT socks, and it was for originally for elite athletes, runners and things like that. And it had all these sensors that could tell, and they could see if your foot is landing properly when you're running. And then, like lots of things in life, you may have an intent to build a system that does one thing, and then you discover it does something else. All of a sudden, doctors said, well, this information we could tell people who, what was it? I don't think it might have been diabetes. It might have been some other ailment. When they noticed when someone started walking a certain way, that was actually a sign of this particular.
Yeah.
Wow.
And so they determined that these socks were like the earliest indicator of all kinds of problems, and the people didn't realize that because the way they walk, their gait, whatever of movement, was an indicator of certain problems or diseases or something like that. And I think that's interesting. But yes, the person as a digital twin, over time, you see people wearing the straps on your chest for really super accurate heart rate and stuff like that, and beats from, I think we're definitely heading that way. We are heading that way. That's what they're already doing that to you a lot when they're in the hospital, right? Yeah. With a lot of expensive machinery. We're going to just, with all these personal wearables and things like that, we're just going to be doing it more and more for consumers or remote medicine. Yeah. But you can imagine, like Star Trek, back in sick bay, you're seeing this whole digital representation of your body and all the stuff going on. Yeah. And we will have all the right equipment on our bodies to get that live telemetry, because IoT is the plumbing, but we've defined you, the twin, and all your attributes, your heart and lungs, and how things are working or not working so well. And so, I think that's going to be a pretty cool thing to watch that evolve, right, in real time, the runtime, and then the idea of simulation. I'm going to simulate turning the volume up to 11, and the twin is going to accurately have your eardrums explode, or something like that. Or you went scuba diving, and you went too fast, too deep under the ocean, and the pressure blew up your ears or something like that, or vice versa. You came up too fast, faster than your bubbles, and you got the bends. You can million scenarios, right?
Yeah, and when you think about it, digital twin is used in the entire workflow of making something like that SOC monitoring your medical condition happen, right? So you're using it. You're developing a digital twin schema or model, and you're simulating it because you have to test on real human beings to determine, okay, what are those signals that indicate and thresholds that indicate that this person has a certain condition based on this model, right? Then you have to then push that model out to whatever IoT-ish type of consumer device or medical device that you're going to market with, then that people wear or medical practitioners prescribe to patients. And then you have that whole runtime monitoring. So there's the use of a digital twin in actually modeling and use in analytics, research. Yeah. And then there's the whole monitoring aspect or management application that gets applied in the end market.
Yeah. We did this thing to you. Yeah. And then what was the outcome? We observed, did you get better? Can you imagine? Right. I mean, think about how fast we got these vaccines created.
Oh, yeah. Yeah.
Coronavirus. You can imagine as we evolve into the future with hyper-accurate-ish digital twins of people and DNA and all kinds of stuff like that, they'll be doing simulations in the future where they will somehow simulate trying out a particular vaccine on a digital twin of a human, and we'll see how the twin reacts. That sounds crazy right now, but it will all happen. Because I learned, folks, that anything you think is silly or a toy or ridiculous and not serious, one day it will eat your lunch and it'll be the thing. So just count on it happening, right?
Yeah, yeah, definitely.
Absolutely. It won't have to have a tricorder.
Yeah.
So,
Tricorder. Yeah.
yeah, totally.
Yeah, it is pretty crazy that these things that we thought were science fiction or that we envisioned 20 years ago, a lot of it is kind of real today, And so imagination lends toward innovation,
It does.
lends
Absolutely.
toward the realization of some of these visions. Because, quite simply, we have tricorder. This is almost a tricorder, right? It has enough sensors right now with a LiDAR and everything to do all kinds of crazy stuff. And think about all the thousands of applications that are on an iPhone or a Samsung XYZ,
Think about the universal translator they had in Star Trek.
But see,
that.
they one-upped Star Trek. They combined a communicator with a tricorder. Think about that now. Steve jobbed Star Trek. Think about that.
Wow.
That's insane, right?
That just happened, folks.
Yeah, that just happened.
Wow. That's a good
Did that
point.
blow your mind or what? No, seriously.
Blew my
Yeah.
mind.
Yeah.
Hey,
Think about
I know
it.
we have lots of our friends and colleagues on the LinkedIn machine, and they say that they're futurists. I know you have friends that say that.
I'm a
maybe
futurist.
You're a futurist. But to your point about sci-fi, I think the true futurists were the science fiction writers
Oh, yeah.
that wrote all these amazing stories and some of those amazing movies, but they're absolutely have led the way.
Yeah.
More than somebody working at a company who says, I'm the official futurist for this big giant corporation.
Yeah.
It was these science fiction writers and creators that
Absolutely.
actually are the true futurists. And so, yeah, that's all that stuff is so important to all the stuff we do. It absolutely leads the way.
Yeah. So how come we don't talk about Buck Rogers? We should be talking about Buck Rogers more. No one ever talks about Buck Rogers, right? I think
Flash Gordon,
exactly.
Thought
leaders.
and also, since Mark loves Queen, he can probably remember and sing for us the Flash Gordon song by Queen,
Queen.
from the movie,
Exactly.
right?
Flash!
Exactly. Yeah, he's following one of us. Yeah.
Yeah.
How about that trippy music, the guitar, man? That was
Yeah.
crazy, weird sounds they were making there in that movie. That was crazy stuff.
Brian May's
Yeah, you
awesome.
cannot watch this movie anymore.
Yeah. Some movies can still
Yeah, I get
last,
too old.
and some they just don't age well.
Yeah,
know-
like a Star Wars, you
Yeah.
still can watch it.
Oh yeah, it's amazing.
Yeah,
So,
that's true.
Mark, tell us, you're pretty much down there in the trenches with all this IoT stuff. What are you seeing? I get the impression you're not really talking about digital twin all that much. And how much do you see your clients or just your peers caring about this stuff? Look at he's shaking
I
his
don't
head, dude.
No, I don't have a lot of experience about digital twin, to be honest. So I let the experts to talk.
Right. But what do you think?
I think it's interesting because if in some specific use cases, I think it makes a lot of sense to talk about digital twin,
Yeah.
like
But-
manufacturing. I don't know if agriculture can happen, but
But what are some of the practical applications that you can think of, because there's a lot of effort that needs to be put into putting together a digital twin and then having sort of the wrapper applications that make it useful, right? So, what
Maybe
are some
they're
of the
the
things
same.
that...
Maybe they're the same apps that we were building just for IoT anyway, and it's just another way of organizing the data. We were already built. My old tagline was always, connect, collect,
Yeah.
analyze, act in IoT. And so we were already collecting data from things, and we were
Yeah.
analyzing the data, and we were taking an action, an event fired, and we did something about it. We fired an event, we sent a message to a person, we found out the robot was going to fail next Thursday, so we flowed a message automatically into ServiceNow to create a trouble ticket so someone could go fix it before it failed. There's already a million apps and things that we think about just with IoT.
Yeah.
I think they're going to be the same ones. I always beat a dead horse talking about how I think of helping digital twins as being helpers to analytics. Because twins are just metadata, and so if it can be a helper for the
Yeah.
analytics to do all those things that we were already building, you know, it's just making life easier for the analytics, right?
Right. Yeah, but so if that was the case, if we've already been doing this in IoT in whatever capacity, I'm just curious to what Mark thinks, because if that was the case, he would just say, "Well, we've been just doing this from the beginning." I mean, what's this net new that you perceive based on all these talks that we've had on digital twin that you think is exciting, or I mean, other than just being interesting, right? Because you're probably the best person to call bullshit on all of this stuff, right? Because in a way, a lot of it is, I mean, I look at it as being, okay, yeah, this is like what you said, Rob, it's metadata. You have a schema for objects and stuff. I mean, it's not entirely a new concept. But what is really exciting about this stuff? Or are we just making a big deal out of a buzzword that just...
We should create a consortium too, and have people spend 150 grand per company.
Well, that's a different thing.
Well, so that we can all sit around and talk about it and go, "Aren't we smart?" Woo!
Yeah. Well, the thing is that at some point, integration and interoperability all become an issue. But there's a lot of, we always talk about it, right? How do you solve that? Well, middleware. Don't even, you can try to standardize stuff, but guess what? You know what? At the end of the day, you want to talk to object or digital twin A and B, process A and B, you have to integrate. And you have to build the interoperability in, and maybe it's a one-off. And guess what? Yeah, it sucks. It doesn't align with any religion, technical religion or standard, but that's friggin' life. You know what I'm saying? And so that shouldn't get in the way of you solving problems, right? It's just Don't wait for the standards to happen and the standards to try to boil the ocean and solve this massive problem called lack of interoperability and integration. That's what you got to do.
Which we should talk about that topic in the future. Just massive interoperability. How do we get there? Because that was one of the promises, or one of the original early things we talked about in IoT.
Yeah.
Was this interoperability, systems of systems all working together. But what really happened is everybody just created new data silos and new closed systems that don't talk to each other, sucking data from machines and making decisions instead of this living thing where everybody's talking to everybody, right?
Yeah.
Someone's got to be bigger than all the other systems. Like if you think of digital twins or objects and how they interact, think about a large system like when we talk about smart cities or connected cars. You have autonomous vehicles, but they need to also talk to each other and the city and the road and street lights, and cars are coming, and how there's twins of all the cars and their objects, and we're detecting them with cameras and LiDAR, and we have logic that's telling the car what to do in case a person runs out in front of the street, right?
Yeah.
Do I hit the person, or do I crash the car into this other car, or whatever? These are all large system problems, right? Where you have multiple actors. It's not just an easy closed system, right? I think twins will flourish more in that level of complexity, just like the human body is super complex like that, right?
Yeah. Well, in a lot of ways, digital twins, from a very practical standpoint, for developers they're just patterns. I mean, it's just like having a class library that you can use, and you don't have to build things from scratch. And maybe to a certain degree, you're going to build some commonality that will lend toward interoperability and ease of integration. So Mark, bullshit or not bullshit?
I remember that I heard about digital twins like 4 years ago, maybe. So at that time, I think it was full of marketing. I don't know, Predix, is it still running or not, and they disappear?
I don't know.
I think
I'm
it's
not
still
sure.
there. I thought I saw a press release somewhere that said
Okay.
it's still on.
Okay.
Might be
No,
on
you're
life
right, because
support,
we
but
heard that G Digital died and laid off 12,000 people, but then later on we heard that they're still alive somehow, or they
yeah,
spun them
they
out.
made it more of a horizontal thing across GE's existing business units.
Okay.
Amazing what happened to that company.
Yeah, I think that the point that you mentioned it's really interesting. So, and as well on this topic that for me it's very key on IoT or computer science, it's a lock-in, no, with a specific platforms or brands. So it could be really this integration, no, or this middleware that can make not to have a digital twin somewhere, but use the tools that are better or the machine learning algorithms that are better from another tool. So these integrations, I think, they will be key in the future.
Oh yeah, yeah. I mean, we still have them. I mean, I was surprised that there could even be a company like MuleSoft existing, given that there's only a few
Enterprise
ERP
service
out
bus,
there. I'm like, what did Salesforce pay for this thing? It's like, isn't like, workflow, business process management. This is shit that we were doing long time ago. It's like, how did we not solve these problems with Crossworld, Vitria, all these different, platforms, these
Maybe that's what the
middleware
technology
platforms.
business is. You just keep
It is.
resolving the same problems with
There you go, baby. Yeah, I mean, I'm just looking at this as like just either we solve a problem, we do something smart, and we forget about it, and then we get into this dumb cycle, and then we solve the same problem again. And I think maybe it's a generational thing, because
I think so.
I talk to folks that are a generation ahead of me, and I'm like shocked that it's like, wait a minute, so this stuff isn't new. So props to the people with experience and
Yes.
some
Because a
numbers
lot of
in their age,
a lot of people will say it's not possible for you to be able to build XYZ solution or system or application without this new advanced technology and scalability and everything. But you're right, it's total BS. Because if old people like me in the early 90s somehow with a tool like Visual Basic on 16-bit Windows 3.1 with only, count it folks, 1, 2, 3, 4 megabytes of RAM,
Yeah.
built rich graphical applications that stock traders were using, because I got started in the fintech world building trading exchanges, which is where I learned to build scalable systems. And so I remember building a mutual fund trading system for one of the big mutual fund companies. And yeah, it was Visual Basic running on Windows 3.1. And then it was talking to Oracle, and you had traders and they're trading mutual funds, and it was real.
You're friggin' old,
but
dude.
people today would say, well, that's impossible. There's no way you could do that. Or you need to scale out to multiple cloud zones with this NoSQL database, or it's not possible. It's like, well, you're a liar, or you just don't know any better, or you're in marketing.
Brutal.
Like people saying, oh, if I don't shard and scale out a zillion versions of my database, I can't do XYZ. And then you would have to remind them, have you heard of the global financial system? Maybe you've heard of stock exchanges and Forex and like how the whole planet operates.
Yeah.
Would you be surprised to know that it's all running on these big ass Oracle databases, relational databases, and they're not sharding out, and they're doing transactions. Remember the old days, they talk about how many transactions per second, and so these databases running on, oh my God, are there still mainframes out there? Oh, as it turns out, yes.
Yes.
The whole financial system is still running on mainframes, folks.
Yep.
Sorry to burst your bubble.
Yeah.
And relational databases, and they're doing billions of transactions per day. And somehow it works.
Yeah.
Without all the new stuff.
And think about it. So we were talking about what do you call futurists, right?
Yes.
Back then, we were all kind of futurists because we were struggling with the limits that we were dealing with at the time, and we envisioned a lot of the things that are happening today, whether it's cloud, DevOps, and being. I remember doing DevOps before there was, wide, broad virtualization of infrastructure, right? And you know what a pain in the ass it was to go through the procurement process of getting the servers that you needed in order to set up your dev, test, and system test, like the 5 or 6 environments that you needed to deploy to support your development lifecycle. And then trying to apply, these DevOps concepts on top of it. We had to do that because we were under pressure to deliver quickly and with quote unquote agility. So we'd already thought through all of these constructs of how to organize, we didn't call them DevOps teams back then. They were our infrastructure teams, but how to organize them in a way to support faster cycles and more agile development amongst our development teams or configuration teams if it was ERP. And so when I hear this DevOps stuff, I'm like, shit, we've been doing this a long time, and I know, just like you, I know the pains. I know what hurt, why we're doing this stuff, because it was really painful trying to really make this agile stuff even remotely useful. Do you know what I'm saying? Without like virtualization of hardware and all this stuff that VMware did, agile just is just some kind of developer's religion.
Since you're an analyst, could you write us a $100,000 paper on agile digital twins?
Agile? No, you don't have to. No such thing. Done. Finished.
No, I think you could
three word paper.
I think you could write a paper and somebody would
agile digital twin DevOps.
Yeah, exactly. And we're going to use DevOps to push the twins up out of the twin pods that we have locally into the slots where all the twins go into the matrix. Which is called the new cloud system of twins that we've got.
No, but it's all cool stuff. I mean, you can only expect that we do things better, but we always seem to be solving the same problems.
Better or the same.
Yeah.
We're making the same money over and over again.
Yeah. There's hope. All right, man. Guys, I'm out of coffee. So why don't we just open up the Clubhouse room and thank everyone who's tuned in to listen to us this week. And we look forward to having you next week. If you haven't already, subscribe to our YouTube channel, which is www.iotcoffeetalk.com. And we will see you next week for another insightful, exciting episode. Right, guys?
We might bring our twins to come talk next week. Instead of us, right?
Our twins.
Our twins are going to come do next week's coffee talk, right? We're going to use DevOps and upload our twins of ourselves into Zoom, and our twins will have the conversations. And it'll be based on past behaviors of the real versions of us that we've copied over time, which is like training a model, right? Pretty soon, no one's going to know the difference. And now you're ready to read my next dystopian novel where... You're replaced by a twin.
Yeah, but not before we shard ourselves.
Exactly. We'll do a lot of sharding.
Yep.
That hurts.
Exactly.
Ow. Oof.
All right. Take care, guys. All right. So let's flip it on to Clubhouse. Take care. Cool. See you next week.